Hello everyone. For this tutorial, I would like to explain how to find triple integrals using cylindrical coordinates, as well as one specific example. Luckily for us, because cylindrical coordinates are very similar to polar coordinates from 2D, we do not have to use an exhaustive proof of the formula like we did for double integral polar coordinates, but instead we can simply reiterate double integral polar coordinates formula and add the change in z, like so. This means we are now integrating at the exact limits of u1 r cosine angle, comma r sine angle, to u2 r cosine of angle, comma r sine angle, and that is for the height of the cylindrical coordinates. For the radius, we would have the same as the radius of polar coordinates, and likewise for the angle, we would have the same angle from polar coordinates in 2D, namely from alpha to beta. So if we are told to evaluate an integral like this, and given that the region lies below the plane z equals x plus 2, and between the cylinders x squared plus y squared equals 1 and x squared plus y squared equals 4 at the same time, we would do this by first taking the limit of z to have a maximum of x plus 2 and a minimum of 0. We now substitute in r times cosine of angle for x because of what we defined cylindrical coordinates as earlier, and because we are given that is specifically between two cylinders of different radiuses but having the same angle. This means the angle must be between 0 and 2 pi, like for any full rotation, and the radius must be between 1 and 2, because we remember that x squared plus y squared equals r squared and not simply r. So we have to take the square root to find the actual value of r. So now that we have figured out the limits of integration, we compute the integral using the triple integral formula, and we make sure to substitute in r sine of angle for y, just like we substituted in r cosine of angle for x. After we do all the techniques for computing the integrals from calculus 1 and 2, we get a final answer of 0. This may be surprising at first, but if we sketch out what all this is stating, we can quickly see why the volume is exactly equal to 0. Now that we've investigated how triple integrals work in cylindrical coordinates, we can discuss how triple integrals work in spherical coordinates next, which, if we remember from when we first studied them, spherical coordinates are more sophisticated than cylindrical coordinates, and are not simply polar coordinates with an extra dimension. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.